Just a quick reminder before we get into the lesson to download the hands-on lab exercises that accompany this complete CCNA course. I'll include the link in the description. Also remember to subscribe and hit the notifications bell so you don't miss any of the lessons in the course. Okay, let's get into it. In this lecture, you'll learn about how EtherChannel Load Balancing works. And I'm going to use the diagram that you see on the slide here throughout this lecture. So I've got two switches which have got 4 links between them that have been grouped into an Ether channel, and each of those 4 links is gigabit Ethernet interfaces. So starting with gigabit Ethernet 0/1 on the left, going to gigabit Ethernet 0/4 on the right. In the bottom switch, I've got some PCs plugged in there. I've got PC1 and PC2. And in the top switch, I've got some servers for server 1 and server 2. So this lecture, we're going to cover how EtherChannel load balances the different flows that are going across the links between the switches. A flow is a communication from a client to a server using a particular application. If PC1 in our example opens a web session to server 1 and PC2 opens an FTP session to server 2, we'd have 2 flows going through our switches. And with EtherChannel, a single flow is load balanced onto a single port channel interface. For example, all packets in the flow from PC1 to server 1 always go over interface gig 0/1. All packets in the flow from PC2 to server 2 always go over interface gig 0/2. So looking at that with an animation, the first packet in the flow from PC1 to server 1, it hits the first switch. The switch decides which interface it's going to load balance it over. It chooses gig 0/1 in our example, and then that goes to the server. The next packet in the flow will also go over the same interface. So it comes into the switch, it load balances it to the same interface again, and then it goes up to the server. On the second flow from PC2 to server 2, that comes into the switch. The switch will use its algorithm to decide which interface to load balance it onto, gig 0/2 in our example, and then it goes to the server. When the second and the third and fourth and so on packets come in from that flow, they'll all be load balanced onto the same interface. Packets from the same flow are always load balanced onto the same interface. They're not load balanced round robin across all the interfaces in the port channel. For example, we don't load balance the first packet from PC1 to server 1 on interface gig 0/1, and then the second packet on that same flow to gig 0/2. The reason for that is that round robin load balancing could cause packets to arrive out of order at the destination, and that would break some applications. So to make sure that doesn't happen, we always load balance packets from the same flow onto the same interface, so they're always going to arrive in order. So if this does not happen, you see the first packet in the flow went over interface gig 0/1, the second packet in the same flow over gig 0/2, we don't do that. So because the way this works, because a single flow always gets load balanced onto the same interface, any single flow receives the bandwidth of a single link in the port channel as its maximum. That's a maximum of 1 gigabits per second bandwidth per flow in our example, where we were using 1 gig links between our switches, but there's an aggregate bandwidth of 4 gig across all available flows. So you can think of a port channel as a multi-lane motorway. The cars always stay in their own lane, in a single lane, but because there's multiple lanes, the overall traffic gets there quicker. Obviously, in our example, if we only had 1 uplink rather than 4, we don't have so much overall bandwidth available between the switches. EtherChannel provides redundancy as well as the load balancing. If a link fails, the flows will be load balanced to the remaining links. Okay, so that's how the load balancing and the redundancy works. See you in the next lecture for more EtherChannel. Thanks for watching. If you'd like to get the complete course ad-free right now, then you can enroll in my CCNA Gold Bootcamp by clicking the link above my head or in the description. It also includes full study notes, quizzes, and 150 pages of additional troubleshooting labs you can't find anywhere else.